Hello, here we are back again in Google Colab. We are gonna see Python lists. So far, we saw variables store single values. Then we saw conditions that make decisions, then loops, which are repeated behavior, functions to organize logic. So, what happens when we need many related values all together? And this is what Python lists are for. What a list actually is, at high level, a list is an ordered collection of values. Conceptually, we can imagine like Luffy, Zoro, Nami, Sanji. We want to store these values orderly under one single variable, for example. Internally, Python lists are much more complicated than basic arrays in lower level languages like C. In Python, they resize dynamically, they store references to objects, so we can have lists of dictionaries or classes or lists of lists. But for now, the important mental model is Python keeps track of an ordered sequence of values. So the basic syntax for creating a list: crew, and then square brackets, and like this. So this is the basic syntax. It's, in this case, it's a list of, all of them are strings and they are comma separated, and all of them are inside squared brackets. And then we assign this list to the variable crew. So for example, print crew and prints out our list. Now, as we saw on Google Colab, which is a Jupyter style notebook, we get away with just naming the variable and running, and it also prints our list. Now, Python will remember each of these values, their order, and their position. So each of these positions has an index, and as we saw on the loops, this is not item number 1, it is item number 0, and then this is 1, this is 2, this is 3. This is very important. So for example, if we want to access crew member number 1, this is not gonna print out Luffy. It prints Zoro because this is Luffy is the first one. So indexes start at 0. And why 0? Well, involves memory and memory addresses, computer science architecture, and everything is zeros and ones. So a 0 these are all memory addresses somewhere, and that's it. It's a computer thing. So yeah, lists start at 0. another thing, out of range errors. So 1, 2, 3, 4. There are four things in our list, right? 4 crew. No, list index out of range. Why? Because again, starts from 0. 0, 1, 2, 3. So 3. Sanji. Now lists are mutable. Strings are fixed, for example. Lists are different. Lists are mutable, meaning their content can change after the create. After we create the list, we can change its contents. So, for example, if we crew square brackets 2, and so we are assigning the string Usopp to the place in our list with an index of 2. So 0, 1, 2. So now, if we print our crew, Luffy, Zoro, Usopp, and Sanji, we replaced whatever was at index number 2. So the list itself stayed being the same object. We just changed a value inside that list. And this is important. And let me try to make that point clearer. For example, backup crew equals crew, right? So we run all, and then if we insert and then we print, backup crew, so crew is this list, and then backup crew equals backup crew. Now backup crew points to this array, and then we came here and modified the array crew on the position number 3 to Sanji. Then we print crew to Usopp, and then print crew and print backup crew. So what do you think would happen? This is still a saved version of the first list, and then this will continue have the changes, but no, both variables are pointing at the same object on memory, this list. So when we change the second index of the list, we changed, there's only one object in memory, this one. These two variables point at the same thing. Okay, this is maybe a little bit complicated to grasp at first. I know I struggle with that concept. So let's get back to normal stuff. So lists can grow dynamically. This is great in Python. Lists have built-in functions, like for example crew dot up, and here's a whole list, right? Crew dot append, clear, copy, count, extend, insert, pop, remove, reverse. So append, for example, chopper. How were we gonna leave our crew list without the doctor? There. Now, crew, run, and there we go. Appended chopper at the end. Internally, Python may even resize memory structures automatically. We don't need to manage that. Python handles it for us. Let's try another built-in list method or function. Reverse. Whoa. Okay. Remove. Crew remove. Remove first occurrence of a value. The first occurrence of a value. That means that if there are a few of the same, it only removes the first one. Comma value. All right. So value. Let's remove Usopp. Sorry, Usopp. Something important. If we remove one of them, now Python automatically shifts indexes automatically. So now this is 0, 1, 2, 3. So crew 3 chopper. Another useful function for a list, a Python list, is length. Python tracks the size of lists, so we can print length of crew 4. But this is a Python function which takes in an object. This is why it was not crew.length. It was print length, and as a parameter it took crew. I don't know if crew.length. I did not see one of those. Index, remove, sort. Nope. I don't know if there is. Maybe Google it. So the most important or most used thing about lists are that we can loop through them. We already saw a brief example of this on the last video. For member in crew, print member Luffy, Zoro, Sanji, Chopper. So it is executing this command each time it loops through it goes through each item one by one on the list and assigns the element to this variable. This can be whatever we name it, like this, right? It's the same thing. This is just a name we place here. We try to place representative names so code is more readable. So what happens if we go like this? For I in range length of crew, print crew I. Will this work? There we go. So what's going on here? Range length of crew is returning the length of the list, and that is placed for the parameter of our range function, which we saw in another video. And then I loops through 0, 1, 2, 3, 4, which is the iterable return by this range function, and then it gets inserted here, right? So it's the same as having put print crew 0 and then 0, 1, 2, 3, like this. Luffy, Zoro, Sanji, Chopper. So this is what actually got executed on this loop. Okay, so this was a little bit more advanced, but it's okay to go checking those snippets of code. So functions combine naturally with lists. Like, let's define a function announce name. What will our function announce do? It will print, I want it to print name, comma, joined the crew. So if we run it, if we call it John joined the crew. But for example, now using our lists, we can do this. For member in crew, now we call our function inside our loop. Luffy joined the crew, Zoro joined the crew, Sanji and Chopper. So our list stores the data in a sequence. Our loop iterates through that sequence one at a time, and then our function organizes a piece of code which gets called each time. Okay, so another useful thing about Python and lists is that Python can also check whether a value exists inside a list without having to, well, it does the looping inside automatically. We just ask it if, like this, if Zoro in crew, so we are asking Python, right? Is Zoro in there? But we are using the if and then this condition to evaluate to true or false. So this will evaluate to true if Zoro is in the crew list. So if this is true, it will print print Zoro found. sort of found. So Python searches through the sequence looking for that value. And if it finds it, it returns true. If it does not, returns false. Now, some common mistakes is forgetting indexes start at 0. We already mentioned this. Accessing positions that do not exist. We already tried, like crew of 5. List index out of range. Also, for example, when we do the functions, the list functions like crew append, instead of using parentheses, Robin, Nico Robin. Instead of doing this, we change this to, we accidentally do brackets. It will break. So now our crew has Robin. Okay, so let's do another example all together. Now with numbers instead of strings, for example. Brackets 3000, 366, and 360, for example. Now, total equal to 0. We are creating this variable total and assigning a value 0. We are creating this variable bounties and assigning an object, which is a list. Now, we are going to loop through our list. Let's name our variable amount. So total is going to be equal of the current value of total plus amount. So it's going to loop through each one of these and assign that value to amount. And then the current value of a total, which is 0, is going to be added to the amount and assign it to a variable total. So then the second time around, this total has a new value, and you see where I am getting at, right? So now let's print total. And there we go. It added the value. So the loop walks through every value in the list, and we accumulate the total over time. This pattern is used a lot in real programs. Okay. So we can also have empty lists. Equals like this. So we are creating a list object which is empty and assigning it to the value treasure. Let's print treasure. Here's our little empty list. Let's use the same cell. So, append, parentheses, remember. gold. Now let's append map. Now let's print treasure. So our little one cell program will create an empty list, print it, then append things to it, then print it again. So there we go. Printed the empty one, then prints a list where we appended some items. So here the structure exists. Then values get added over time. Let's say our program here is very long and does a lot of things, and then we append things to it. This is also very common in real applications. So lists are one of the foundational structures in programming, not just in Python. Almost every programming language has some version of this idea, an ordered collection of values. So essentially, so we can loop through them, store them, and then search something in it. And now, so our programs can manage data at larger scale. So I think that will be it for this video. Next video we will see dictionaries. So thanks a lot. Thanks for watching. See you in the next time. Bye bye.